So now let's talk about something really big. You know, VR is going to be an incredibly big platform. I'm super excited about that. One of the biggest things that's ever happened to computer graphics, but one of the biggest things that's ever happened to computing. And I think we're going to realize, looking back, that this is one of the biggest things that's ever happened is AI. 5 years ago, the big bang of modern AI happened. Amazing AI computer scientists discovered new algorithms that made it possible to achieve levels of results and perception using this technique called deep learning that nobody had ever imagined. But the confluence of several things happened. The availability of lots of data that was labeled, and the availability of a processor called a GPU that was really abundantly used, abundantly available, came together and created the big bang of modern AI. Over the course of the last 5 years, so much development has happened. You have seen one announcement after another announcement, one article after another article, and there's so much to capture. But I think as we look back on 2015 is going to be a defining year for modern AI, and I argue for computer science, for computer industry, and very, very likely for all of humanity. That this year marked something quite special. That every year is a good year, but 2015 was a very special year. This year, something happened, and I selected a few to talk about. ImageNet, Microsoft and Google, using deep learning techniques, was able to recognize images better than a human for the very first time. A software program is able to perceive the world. A software program is able to perceive the world. A single algorithm was able to perceive the world better than any human. And then Microsoft took that level of accuracy and doubled it using a very super deep network. Whereas AlexNet was about 18 layers deep, their network was 180 layers deep. These networks are now so deep, it's able to pick up subtleties and nuances in images, and its ability to be accurate, unsurpassed now by any human. Superhuman levels of capability. But the thing that's really cool is it wasn't being trained. People are finding new application for it. It's not just images. Now researchers at Berkeley, at the Berkeley AI lab, was able to use the same deep learning algorithms, the same deep learning networks, combine it with reinforcement learning, and taught a robot how to control its own motor skills. Using simply a camera and 800,000 tries, this robot was able to fit a square peg in a square box. It's able to hang up clothes. It's able to screw a bottle cap on. Could you imagine writing a software program to do that? To screw on bottle caps? Well, it turns out that those programs, we haven't figured out how to write, but we have figured out one algorithm called deep learning that is now allowing robots to learn by themselves. The generality of this algorithm is quite fantastic. Baidu used the same network to train one network, 2 languages, English and Chinese. Deep learning has captured the imagination of so many people that it has gone pop culture. I don't remember the last time Rolling Stones wrote about computer science. Rolling Stones had a big spread on deep learning, on its implication of this new field. And of course, we can't overstate the achievement of Demis over at DeepMind and all of his researchers with AlphaGo. You simply can't overstate the importance of that. This is a simple game, 19 by 19 grid, 365 places you could place a stone, a black or a white stone, and the purpose of this game is deceivingly simple. Your objective is to surround the opponent's stone and capture that stone, or build a fence around an open territory and capture the territory. That's the only objective. However, the number of combination of moves, the number of board configurations is staggering to the mind. It's millions of times more complicated than chess, which has 16 pieces, 64 squares, And each one of the pieces have different constraints on them, so the possibilities of moves, the configurations of the board, is not nearly as complicated as Go. This 2,500-year-old game. And the year that Deep Blue beat Garry Kasparov on chess, physicists said that it will take another 100 years for a computer to master Go. That they thought it would take another 100 years. Because the computational complexity of Go is practically infinite. It's practically infinite. And yet, this year, using deep learning algorithm, using reinforcement learning, Demis and his team created AlphaGo and took on the best living player of Go. Now, I think that it's also just an incredible testament, because we understand what AlphaGo is the technology that has made AlphaGo possible. It's running on 1,000 CPUs, on 200 GPUs. It's trained on the moves and the board configurations of experts in history of Go. And then it played itself millions of times. It played itself millions of times, one game after another, as it discovered new strategies to win. And then Lee Sedol of Korea was able to challenge this computer and stay toe-to-toe. He ultimately lost 4-1, but I think it's just a celebration of his genius that a human could take on this supercomputer powered by deep learning, powered by AlphaGo, trained over millions of games, and to be able to take a game off of AlphaGo. Pretty amazing achievement by Lee Sedol. But what this says is that finally, computers powered by deep learning has the opportunity to do things that we can only dream of doing. That it can now develop algorithms. Now this algorithm can perform tasks that we can't actually imagine writing software for. Deep learning is no longer just a field. It's no longer just an app. It's no longer just an algorithm. I believe deep learning is way, way, way bigger than that. And it's one of the reasons why our company has gone all in on deep learning. You've heard me talk about deep learning now for about 5 years. And every single year, we do more and more in this area. We think this is so important. We think that this is going to utterly change computing. We think that this is a brand new computing model. Deep learning is a big deal. Now, the way to think about this is rather simple. Back in the good old days, we still do plenty of that today, domain experts, computer scientists, would type commands into a box. We type commands into a box. Now, these commands are, of course, computer science is really, really a very finessed art. It is really quite broad. It's deep. Computer scientists, geniuses all over the world, they arguably, in the final analysis, type recipes into a box. Now, these recipes, of course, are really finessed, and they do amazing things. But they're ultimately written by domain experts. Each recipe, each dish is a different recipe. If you would like to have a computer program that looks at images, that's one program. If you have a computer program that would like to understand languages, a different domain expert would write a different program. If you would like to have somebody write a program that, for example, sorts a whole bunch of numbers, somebody would be a sorting expert and writes a different program. However, in deep learning, it's one general algorithm. There are many configurations of it. There are many different architectures of it, but in the final analysis, the basic approach is very similar. It's one of the reasons why the folks at Baidu with Deep Speech 2 was able to use exactly the same network to do two different languages. You didn't need a Chinese expert and an English expert to teach that network. It's the same expert. It's just one algorithm. And yet that algorithm could be used in Brett for motor skill detection and motor skill learning. And yet that same approach could be used for AlphaGo to learn how to play Go. And that same approach used by Demis and his team was the same approach that they used to play Atari games. Using one general architecture, one general algorithm, we're now able to tackle one problem after another problem after another problem. The fundamental difference is this. In the old traditional approach, programs were written by domain experts, and it took time. It took time and refinement. In this new approach, you have a general algorithm called deep learning, and what you need is massive amounts of data and a huge amount of high-performance computing horsepower. Fundamentally different approaches for developing software. The benefits are very, very clear. On the right-hand side, you see ImageNet. The blue dots are human-written feature detectors. These are computer vision experts that have dedicated their careers and their lives to detecting objects, detecting things, using computer vision algorithms. And yet, researchers who are not experts in computer vision was able to design this architecture, this network, feed it with thousands and thousands of images, crunch it in hours and hours and days and weeks of high-performance computers powered by GPUs. And as a result, the results, as you can see, speaks for itself. It is now superhuman. This computing model has not gone, what is the phrase for that? Unnoticed by the industry. What started out in research, we had the good fortune of working with these amazing researchers on GPU computing all along, 5-6 years ago. But starting in research, it moved to technology platform providers who are now taking this basic approach and incorporating it into frameworks and engines. Companies like Facebook and Google, TensorFlow, Microsoft CNTK, Torch, Theano, Caffe. These frameworks are essentially the EDA tools of modern network design. It is the, if you will, EDA design tools that we use for designing chips. These are the EDA design tools, the environments for designing neural nets. Is essentially the tools, 3D authoring tools for designing neural nets. These frameworks are of vital importance to the development and the acceleration of AI. We work hard to put CUDA underneath every single one of them and accelerate each one of these frameworks to its limit. The library that we use to do that is called cuDNN. Beyond the core technology and frameworks, it's now moving into platforms. One of the most important things you're starting to see is AI as a platform. Amazon has AI as a platform. It's basically an operating system of AI. Voice recognition, image recognition, gesture recognition, so on and so forth. All of these services are now part of a cloud platform. Amazon has theirs, IBM has Watson, Google has theirs, and Microsoft has Azure. Cloud platforms in the future are going to be powered by AI. Startups are cropping up everywhere. Just yesterday, I think MetaMind was bought by Salesforce.com. DeepMind is now part of Google. The importance of AI can't be overstated. Great, cool startups are showing up everywhere. We understand there's some 1,000 startups. We're interacting with hundreds of them. $5 billion just last year invested in AI startups. This is the most important field, one of the VCs told me, the most important field that they're investing in today. And now it's going into industry. Just as web has, just as cloud computing has, just as mobile computing has, started out in research, started out in core development, moved out into platforms, moved out into startups, adopted by large companies far and wide. The industries that support, that are now looking into AI, are the obvious and the not obvious. The obvious ones are the ones with millions and millions of customers. Retail companies, companies with a lot of data, company who needs to make sense out of a lot of data. Life sciences companies, medical research. Companies that you wouldn't have thought of, for example, IoT, they're going to be sensors connected all over the world. What GE calls the industrial internet is basically industrial internet connected to artificial intelligence. To be able to monitor elevators all over the world, power distribution systems all over the world, the smart grid. There's no way to write a single algorithm to understand how everything is behaving out there. Nothing is better than using an AI algorithm to monitor what's happening all over the world and to discover some insight to give you some early warning signs so that you can go take care of a piece of equipment that's about to fail. Industry after industry after industry, deep learning is now sweeping through them.